Hello. Hello to everyone. Good evening. Good evening, Kamal Gupta. Good evening to one and all. Welcome to Gate Academy. Sorry for the delay. Yeah, I hope students are joining slowly. Hi, Neeraj Kumar. Good evening. Good evening. Good evening. So, all of you are fine. कल का सेशन एंजॉय किया आपने सब लोग? कल का सेशन बहुत एंजॉय किया ना, जो कुछ हमने डिस्कस किया एरर एनालिसिस पार्ट 1 पार्ट 2 दोनों पार्ट्स डिस्कस किया हमने. या ममता कुमारी, गुड इवनिंग. So we have discussed two topics actually on error analysis. Two topics we have discussed. Good evening to one and all. Mamta Kumari, you are coming for first time for my class. Okay. Welcome to all. Welcome to Gate Academy. Now we'll start the session. So in the last class, hi Ruchita, good evening. Good evening. Almost I'm covering the whole subject, right? I'm covering the whole subject. Chalo. Yesterday we have discussed some questions. Today some more questions we'll discuss. So before discussing that, so this one, uncertainty error. Yes, I am discussing. Okay, chalo. What is uncertainty? So some people are asking how to find out the uncertainty. Okay, dear students. So how to find out the uncertainty? मैं ऑलरेडी अभिषेक आई हैव कंप्लीटेड पूरा सेंसर्स का क्लास भी खत्म हो चुका है. मैंने सेंसर का क्लास भी खत्म कर चुका हूँ. ओके अभिषेक दास, मैं सेंसर एंड ट्रांसड्यूसर पढ़ लिया ऑलरेडी. 25 आवर्स का क्रैश कोर्स हो चुका है. हाय सुजीत यादव, गुड इवनिंग. गुड इवनिंग टू वन एंड ऑल. सी ऑलरेडी आई हैव कंप्लीटेड सेंसर्स. दिस इज मेजरमेंट्स. वी हैव टू yet to start optical session. Yet to start optical session, but right now sensors is completed. measurements का चल रहे. so चलो we will start the session. बहुत लेट हो गया already. okay, so if you see this one, so this is the uncertainty error. So people are asking what is uncertainty? Actually uncertainty is a type of error by considering its a propagation of errors. See, suppose x is a function of some variables. X is a function of variables f of x1, x2, xn, where x1, x2, x3 are independent variables. They are not dependent to each other, they are independent. That means x1 is not dependent on x2, x2 is not dependent on x3. अच्छा अच्छा, okay okay. ओके बिकॉज सर मेरा ब्रांच ट्रिपल है इसलिए पहली बार देख रही हैं. ओके नो प्रॉब्लम, यू कैन फॉलो ऑल द सेशन. जो कुछ रिकॉर्डेड है वो भी देख सकते हैं आप. जो कुछ रिकॉर्डेड सेशंस है ना वो भी देख सकते हैं. नो प्रॉब्लम. ऑलमोस्ट वी केम टू द एंड. ये 21 लेक्चर है. लेक्चर नंबर 21 है ये. अब तक 20 लेक्चर्स खत्म हो चुका है. 20 लेक्चर्स खत्म हो चुका है. मैंने डिस्कस किया पूरा मेजरिंग इंस्ट्रूमेंट डिस्कस किया, पीएमएमसी डिस्कस किया, मूविंग आयरन डिस्कस किया, इलेक्ट्रो डायनेमोमीटर टाइप वाट मीटर डिस्कस किया, इलेक्ट्रोस्टैटिक वोल्ट मीटर डिस्कस किया, डीसी ब्रिडजेस, एसी ब्रिडजेस पूरा डिस्कस किया, एरर एनालिसिस भी डिस्कस किया. अभी एरर एनालिसिस का बाकी क्वेश्चंस कर रहे हैं हम. ओके आप देख सकते हैं पूरा 20 लेक्चर्स में आपका सेशंस मिलेगा आपको. चलो चलो. नाउ लेट अस सी दिस अनसर्टेनिटी एरर. हाउ टू कैलकुलेट दिस क्वेश्चन इज वेरी वेरी इंपॉर्टेंट. व्हाई? बिकॉज इन सर्टेन एग्जाम्स ही आस्क्ड अनसर्टेनिटी. सो अनसर्टेनिटी एरर क्या है? अनसर्टेनिटी बोलो तो क्या है? अनसर्टेनिटी, whenever a particular parameter is a combination of some other parameters. If x is a function of other parameters, x is a function of x1, x2 and so on, and suppose each parameter is independent of the other. Each parameter is independent of the other, not dependent. Okay, and wx1 and wx2 and wxn are their uncertainties. Uncertainty is a type of error. Okay na? x1 का uncertainty wx1 and x2 का uncertainty wx2 and xn का uncertainty wxn, that is a representation. Then the total uncertainty error of x is given by wx. So wx का function is given by square root of 2x by 2x1 होल स्क्वायर, అంటే पूरा फंक्शन को इंडिविजुअल पैरामीटर्स से पार्शियल डिफरेंशिएट करके उसका स्क्वायर लगाना, एंड अगेन वी हैव टू मल्टीप्लाई इट्स इंडिविजुअल अनसर्टेनिटी एरर्स. ओके ना. सो वेयर wx1, wx2, wxn आर देयर इंडिपेंडेंट absolute errors. See here. So कैसा करना है? Suppose x is a function of, again I am writing here for all of you, x is a function of x1, x2, x3, so on, xn. Then uncertainty error in x. Uncertainty error in x is given by square root of dou x by dou x1 whole square into uncertainty in x1 whole square plus dou x by dou x2 whole square into uncertainty in x2 square. Uncertainty in x2 square. So plus or minus लग सकते हैं. समझ में आपको? Please all of you note down this point. Please all of you note down this point so that in exam you are going to get पक्का एक question. Okay? So most expected question है, क्योंकि normal errors nobody can calculate. Normal errors everybody can calculate, but uncertainty error is a type of error by considering the history of errors. ये uncertainty का मतलब क्या होता है? What do you mean by uncertainty? Uncertainty is not based upon only one value. Uncertainty is based upon a history of values. History of values. For example, एक location है. In one location, suppose for example if you take Chennai, in Chennai June July में getting the rains is very very uncertain. In June July getting the rains is very very uncertain, but in November December getting the rains is very certain. How they will tell this? Over a period of data from the last 10 years they will observe 2010 June July, 2011, 2012, 13, 14, 15, 16, 17, 18, 19, 20. So they are considering the last 10 years data. Based on that, getting the rains in Chennai in the month of June, July is uncertain. So uncertainty error is calculated based upon not only the past, based upon not only one value, it is based upon the history of the data. That type of errors are called uncertainty errors. Okay ना? चलो समझ में आपको सब लोगों के लिए फार्मूला लिख दिया. Everybody has taken this formula. Now I am going for a question. Shall we go for the question, dear students? All of you get ready for the questions. So please all of you show me the thumbs. We are going to start the questions. So question कैसा आता है देख एक बार. So this is the question. See, try to do this question. Yeah. Try to do this question. Fast. Two resistors R1 and R2. Two resistors R1, R2 connected in series. The values of resistor R1 with plus or minus 0.1 ohms, R2 50 ohms plus or minus 0.03 ohms. Calculate the uncertainty in the combined resistance for series operation. So these are the uncertainty errors. And he is asking series combination. So कैसा करना है? For series combination, R will be R1 plus R2. That everybody knows. R1 plus R2 कितना होगा? 100 plus 50, 150 होगा. That's okay. But we have to find uncertainty in R. ये कैसा calculate करना? Uncertainty in R. How to do it? See, dear students, let us see here. We'll use this function. Capital R is equal to R1 plus R2. Suppose if you partial differentiate dou R with respect to dou R1, what I am going to get? Dou R by dou R1, differentiation of this with respect to R1, that will be 1. Dou R2 differentiation with respect to 1, this will be 0. So this will be 1 or not? Yes or not? Please show me the thumbs. Similarly, dou R by dou R2. Dou R by dou क्या होगा? Partial differentiation of this entire function with respect to R2 this will be 0 and partial differentiation of this width will be 1. So resultant will be 1 or not? Yes. Now what is the uncertainty in R? Uncertainty in R will be equal to square root of dou R by dou R1 whole square, dou R by dou R1 whole square, and uncertainty in R1 square plus dou R by dou R2 whole square, and in uncertainty in R2 square. Uncertainty in R2 square. Am I right? So खत्म कर दीजिए. So what is the answer? दो R by दो R1 कितना है? 1 square. Uncertainty in R1 कितना है? Uncertainty in R1 if you check, that is 0.1 ohms na. So this is the WR1 or not? Uncertainty in R1 is 0.1 ohm. Uncertainty in R2, WR2, that is equal to how much? 0.03 ohms na. So if you substitute that, so how much you are going to get? So one is 0.1, 0.03. So this is 0.1 whole square plus this will be 1 square and 0.03 whole square. Can you tell me the answer? Please tell me the answer. Fatafat, Ruchita, Rahul Jaiswal, Mamata Kumari, have you followed? Abhishek Das. So try to tell me the answer. Kitna aa raha hai aapko? Please use the calculators. Please use the calculators. Please use Calci. I'm using the Calci. You also use Calci. How much are it? So 0.1 square plus 0.03 square, square root of answer. You are getting 0.1044. Am I right? 0.1044. 0.10440. Yes or not? 0.1044. Yes or not? Sir, partial differentiation of partial R1 and R2 का term होता तो 150 रखते क्या? 150 क्या? नहीं यार, you are making partial differentiation of R1 with respect to R1. This entire partial differentiation you are doing here. This R is a function. R is a function of R1 plus R2. Partial differentiation of this total with respect to R1 क्या होगा? ये एक same identical term है. This will be 1. R2 with respect to R1 is constant. So partial differentiation of this with respect to R1 will be 0. So 1 होगा. ये पूरा function में R1 you are see this पूरा function you are differentiating this entire function with respect to R1. When you are differentiating with respect to R1, this term will be 1 and this term will be 0. Why? Because differentiation of R2 with respect to R1 will be 0. Similarly, dou R by dou R2 में partial differentiation of R1 will be 0. Partial differentiation of R2 with respect to R2 will be 1. भैया एक बार check कर दीजिए आपको, गजेंद्र सिंह. Yeah, 0.1044. So what is the correct answer now? The correct answer होगा 150 ohms plus or minus 0.1044 ohms. All of you understood, dear students? So this is the answer. This is the answer. 150 ohms plus or minus 0.1044. Clear? All of you understood? Shall we go for the next question? Fatafat. We are going for the next question. एक बार check कर दीजिए. R1 R2 है, R1 R2 है ना? R1 R2, R1 R2 है तो you have to substitute. चलो next question. Yeah, 0.1044 ohms is the answer. Next question. Yeah, try to do this question, all of you. Yeah, try to do this question. Yes. Okay, Gajendra, try to do this. ये क्वेश्चन क्या है देखो, A resistor has a nominal value of 10 ohms plus or minus 1%. A voltage applied across resistor and the power consumed in the resistor is calculated by using P is equal to E square by R. Okay, so there is a voltage like this. So this is E and here comes a resistor. Here comes a resistor. Here comes a resistor. Calculate the uncertainty in the power. So what is the power dissipation here? So the power dissipation here is equal to I square R. I is equal to E by R. So power dissipation will be E square by R. Power dissipation is E square by R. So E का value दिया है 100 volts plus or minus 1%. All of you are following, dear students? So this is 100 volts plus or minus 1%. That means how much here? 1% of 100. 1% of 100 means how much? Fast. 100 into 1 by 100. So that will be 1. That means 100 volts plus or minus 1 volt. 100 volts plus or minus 1 volt. Correct? Next, इसमें क्या है 1%. इसमें क्या है 1%. So this में 1%, R में 1%. That means 10 ohms into 1 by 100. That will become 0.1 ohms na. So this is 10 plus 0.1 ohms. So uncertainty in resistor. Uncertainty in resistor is 0.1 ohms. Okay na? Uncertainty in voltage. Uncertainty in voltage is 1 volt. All of you are following, dear students? Please show me the thumbs here. Please show me the thumbs. What I am doing is question asked is power. Power का फॉर्मूला क्या होता है? E square by R होता है. E में अनसर्टेनिटी है, R में भी अनसर्टेनिटी है. E में एरर दिया है 100 volts plus or minus 1%. 1% of 100 volts. 1% of 100 volts means 1 volts. That is plus or minus 1 volt होगा. And in resistor there is a error of 1% of 10 ohms. 1 by 100 of 10, that will be having error of 0.1 ohm. Now if you get what is the uncertainty in power, how to do it? See, power का formula क्या है? Dear students, try to follow my solution. Power का formula क्या है? Power dissipation is equal to E square by R. Okay na? So I will remove this D so that you will get confused. So power is equal to E square by R. So कैसे calculate करना पहले? So we have to do with respect to 2p by 2e ना, 2p by 2e. So 2p by 2e क्या होता है with respect to variable e? Okay ना? So 2p by 2e कैसा होता है? So 1 by r as it is, e square का 2e होगा, e square का 2e होगा. Next 2p by 2r क्या होगा? 2p by 2r क्या होगा? E square as it is, 1 by r partial differentiation will be minus 1 by r square na. Minus 1 by r square na. Please, all of you understanding or not? Please show me the thumbs. I am taking the partial differentiation of E. Partial differentiation of P with respect to E. Then that will become 2E by R. Partial differentiation of P with respect to R. That will become E square by minus R, 1 by R square. Yeah. Please let us find the values first. So what is the value of E and what is the value of R? Please go back to the question. The voltage value is 100 volts and the resistor value is 10 ohms. So this will be 100 by 10. So you will get 20. Next, this will be how much? Minus E square. E square means 100. E square means 100 na. So 100. 100 square by R square. R square is 100. So एक 100 खत्म हो जाएगा. एक 100 खत्म हो जाएगा. So you will get minus 100. Am I right? So this is minus 100. Correct or not? चलो. Now uncertainty in power कैसे calculate करना? Uncertainty in power. Uncertainty in power will be taken as square root of 2p by 2e whole square into uncertainty in voltage whole square plus 2p by 2r yes or not whole square in uncertainty in r square or not? Yeah. So how to do it? 2p/2e कितना है 20, सो 20 स्क्वायर। अनसर्टेनिटी इन एरर, अनसर्टेनिटी इन ई कितना है, अनसर्टेनिटी इन ई इज 1 वोल्ट ना, यस 1 वोल्ट, सो 1 स्क्वायर प्लस 2p/r कितना है, 2p/r इज -100, सो -100 होल स्क्वायर इंटू अनसर्टेनिटी इन r, अनसर्टेनिटी इन r कितना है, अनसर्टेनिटी r इज 0.1, समझ में ना आपको, so 0.1, please calculate and tell me how much is the answer, please calculate and tell me. Square root of 500 na, so you are getting square root of 500, so square root of answer is how much, 10 root 5, 22.36 ना, how much you are getting, एक बार चेक कीजिए, I think it will be 22.36, excuse me, so power uncertainty कितना होगा, e square by r, so e square by r, e square is how much 100, see I will do the total calculation, so power with uncertainty क्या होगा, so resultant uncertainty power कितना होगा, e square by r, what is e, 100 square, what is r, r is 10 ohms, r is 10 ohms, am I right or not, e is equal to 100 and r is equal to 10 ohms, so that will be what, 10,000 लो एक जीरो कट हो जाएगा, 100 into 100, 100 into 100 by एक जीरो कट हो जाएगा, so that will become 1000 watts, 1000 watts plus or minus, what is the answer, 1000 with the uncertainty of how much, 22.36, clear है आपकी, all of you understood, so this is the answer, that is the answer, all of you understood, so these are the ways to do the problems, Rahul, very good. These are the ways to do the problems. What about other students, all of you followed or not? Kamal Gupta, clear? So power is actually this is the true power, this is the true value and this is the uncertainty. So this is the power value and this is the uncertainty in the power. Uncertainty in the power. Chalo, these are the main questions. With this we have completed the errors. So subtypes of error calculations we have done, yes or not? Yesterday we have done absolute error, yes or not? Remaining students, all of you show me your thumbs, Gajendra Singh and other students. I need your response, I need your thumbs and pair symbols and everything. You please express your understanding, whether you have understood or not. Best lectures of error analysis. Thank you Gajendra Singh. Actually this is the third session. I am taking on error analysis, Kamal Gupta. First session I have taken on basics of errors. Basics of errors like absolute error क्या है, relative error क्या है, percentage error क्या है. And yesterday we have taken some errors, resolution problems, meter resolutions ऐसा है. And today we have taken uncertainty which covers the total error package. Okay, चलो now आज का topic start करेंगे. आज का topic है Q meter. आज का topic है Q meter. How many of you know about Q meter? Q meter is all about the Q factor. Am I right or not? So what is Q factor? Q factor का मतलब क्या है? Q factor is also called quality factor or not? Quality factor is also called figure of merit or not? Quality factor is also called figure of merit of a coil or not? Figure of merit of a coil or not? Okay na? Figure of merit of a coil. So it represents what? It represents the how much energy is going to be stored. What is the ability of the coil to store the energy? Yes or not? Yes. Calculate and quality. Yes, yes, yes. Quality factor. Okay. So we are going to do some questions on quality factor. Kamal Gupta and Mamata Kulkarni and Kamal, all those people. Okay. So we are going to calculate the quality factor. Or quality factor calculate करने पहले. Quality factor is a property of a coils. yes or not, especially for the coils. So why? Because energy storage elements are coils and capacitors. Energy storage are coil and capacitors. So I have collected some beautiful information. I think all of you know the Q factor ka formula. For a coil it will be omega L by R, yes or not, quality factor of a coil, and quality factor of a capacitor will be given by a formula 1 by omega CR. So it is very clear that quality factor purely depends upon the omega. Omega means frequency. So quality factor depends upon the frequency. Am I right or not? Yes. Gate 2020 में question आया Q meter पर. So let us start the session directly. We will go to the session. I have collected some information. Chal. Well, see what is the Q meter. See, Q meter is basically comes in the resonant circuit of RLC. Yes or not? So I think all of you know this basic of network theory में आपको आएगा RLC series circuit, resistor, inductor, capacitor. So when a particular circuit is maintained in a resonance, at resonance we are going to get this concept of Q meter. Yes or not? So operating principle is based upon the series resonance in RLC circuit. One of the expected question, Q meter works on which principle? Series resonance. Series resonance of RLC circuit. So what is series resonance? I think everybody knows that. Everybody knows that at series resonance, XL is equal to XC na. Inductive reactance and capacitive reactance both are going to be equal or not at resonant frequency. So these everybody must know it. Everybody must know it. Okay. So at resonant frequency in a circuit of RLC, this is a resistor, this is an inductor, this is a capacitor, XL is equal to be XC. XL is going to be XC. Suppose if you take the phasor diagram, for a phasor diagram, if I am going to take a phasor diagram for example, dear students, listen, phasor diagram, suppose if you are taking, this is the current, okay na? This is a current, the voltage across the inductor, in inductor the voltage leads the current or lags the current. For inductor VL is equal to L into di by dt. For a voltage across the inductor, it leads the current or lags the current. I told you always to remember this technique. You have to remember civil technique. Civil is a technique to remember. In civil, in capacitor, current leads the voltage. In capacitor, current leads the voltage. In inductor, voltage leads the current. Am I right? In inductor, voltage leads the current. Am I right or not? Voltage leads the current. Yeah, voltage is going to lead the current in inductor. So we are going to get the voltage function here or not? So if you take, this is the voltage, so that is what? I into XL. I into XL. Am I right? So this is the voltage across the inductor. Am I right or not? Sir, 90 degrees se lag karta ji. Yes or not? Yes, Mamta Kumari, correct. Current lag karta hai. Very good. Current is lagging by 90 degrees na. That's what I have written. Current is lagging na. So current is lagging, voltage is leading. Okay. So next, what about the capacitor? In capacitor, current leads the voltage na. In capacitor, current leads the voltage. So if you see the voltage across the capacitor, so both are having same magnitude. So this is the voltage across the capacitor. Dear students, listen carefully. So this is the voltage across the capacitor. So this is IXC. Okay na? So at resonance, these both are equal. At resonance, these both are equal. At resonant frequency, what happens? XL is equal to XC na. I think all of you know that graph. I think all of you know that graph, right? I think all of you know that particular graph in XL. XL is equal to omega L. xc is equal to 1 by omega c, 1 by j omega c, yes or not, 1 by omega c. So here xl is equal to 2 pi fl, here xc is equal to 1 by 2 pi fc, 1 by 2 pi fc. Here as the frequency is increasing, xl is going to be increasing. So if you draw the graph between the frequency and xl, as the frequency is increasing, xl is going to be increased. Here as the frequency is increasing, xc is going to be decreased. So at a particular point called resonant frequency, which is called resonant frequency, at resonant frequency what happens, inductive reactance and capacitive reactance both are equal. When inductive reactance and capacitive reactance, this is our XL and this is our XC. समझ में आपको? Okay, so you can take this as XL. XL is increasing and this XC is decreasing. समझ में आपको? As a frequency is increasing at a particular point, XL is increasing. As a frequency is increasing, capacitive reactance is decreasing. At a particular point, what happened? There is a cross section. XL is equal to XC. That means capacitive reactance and inductive reactance both cancel to each other. Then the circuit becomes as purely resistive, na? I think all of you know these points or not? Yes. At resonant frequency, the circuit becomes purely resistive or not? RLC circuit becomes a purely resistive circuit. Am I right or not, dear students? All of you studied this now? That's what I am drawing here. Dear students, listen. Now both are going to be cancelled and the voltage across the inductor voltage across the inductor and voltage across the capacitor both cancel, and the resistor component, the voltage across the resistor is nothing but E naught, that is E, supply voltage E will become I into R only, na? The voltage, the circuit will have only IR resistor, na, dear students? Yes, purely resistive. Kamal Gupta, very good. That's what I have written, dear students. See, I have taken an R circuit, I have taken an L circuit, I have taken a capacitor. So across this capacitor, I am measuring the voltage by using some variable capacitance. This is EC. So this is EC and this is E. Now if you see this particular function, dear students, see, if you see this particular function, what is happening? At resonant frequency, Xc is equal to XL. So we are going to get a formula for resonant frequency. Xc is equal to 1 by omega C, XL is equal to omega L. So we are going to get the resonant frequency formula. So what is the resonant frequency formula? Fr is equal to 1 by 2 pi square root of LC. Am I right? So this is not going to happen at all frequencies. At a particular frequency called resonant frequency, at that particular resonant frequency, then what happens? If you check detailedly, what happens? See, now what is happening? All of you listen carefully. These all theories I have kept for you. Listen, current at resonance will be nothing but E by R, na? Why? Because XL and XC both cancel to each other. So current will be E by R. Voltage across the capacitor is I into XC and voltage across the capacitor XC is equal to XL. So both are same. So now if I am taking the output by input, see what is the beauty of this circuit is, by using the concept of resonance, I am going to find out voltage across the capacitor will be I omega L. Why? Because IXC is equal to IXL. In the place of XL I have kept omega L, and voltage in the loop is nothing but purely resistive. So we are going to get Q factor phenomena. Dear students, listen carefully what I want to tell you. Here, see here, this circuit I want to explain you once again. See here, at this particular point, if you take the output voltage at resonant frequency, at resonant, XC is equal to XL, na? XC is equal to XL, okay? At resonant, XC is equal to XL, and 1 by omega C is equal to Z. So if you take the output voltage EC by total voltage, that is purely resistive voltage E, EC is nothing but now I into XC, and E is nothing but I into R. Am I right? Dear students, clear? I into X is nothing but I into XL. Am I right? Am I right or not? Why? Because X is equal to XL and I into R. I into R. I gets a cancel. So EC by E is nothing but XL by R. XL by R is nothing but omega L by R. That is nothing but Q factor. That means directly you got the reading of Q. So Q factor ka reading aa gaya EC by E na. That means what do you understand? By taking the voltage across this particular capacitor at a particular capacitor value and this voltage, the ratio of this is 2 is giving directly the Q factor of the coil na, dear students. Yes or not? Do you understand, Kamal Gupta? By adjusting this particular capacitor, I am making this particular EC is equivalent to E. Then that is going to happen at a particular Q factor of this coil or not? Do you understand this value? So EC by E ratio is giving as Q. Uska matlab kya hai? When EC and E both are equal, we are going to get the Q factor or not? So I am adjusting this capacitor. I am adjusting this capacitor to a certain voltage such a way, then EC is equal to E. Are you understanding? So we are going to have a Q factor. That's what. So Q factor of a coil. समझ में आपको? The coil का Q factor कैसे पता चलेगा आपको? How to get? A unknown coil is given to you. Kamal Gupta, a unknown coil is given to you. I am going to keep the unknown coil here. I will go on adjusting this particular voltage of the capacitor. At a particular voltage, this EC will be equal to E. Now, if you take that both ratio, I will get the Q na. Do you understand? Once again, I am telling. A unknown coil is given to you. I am asking you to find out the Q factor of this unknown coil. What you will do? This unknown coil you will keep here and you will go on adjusting this capacitor. This voltage is known to you. This voltage is known to you. This voltage must be known to you. And this voltage you are going on adjusting by changing the capacitance value. You are going on adjusting. We are using the variable capacitor. And variable capacitor you are going on adjusting the value of voltage across the capacitor. At a particular value of voltage across the capacitor. For a particular value of capacitor, the voltage across the capacitor and the voltage of supply both will be equal. Now when you achieve that, if you take that particular ratio, that will be nothing but Q factor of the coil. So this is what actual theory, true value of the Q factor. Okay. Now dear students, clear na? All of you clear about this? Please show me the thumbs. So how to find out the Q factor of an unknown coil? Take that Q factor of unknown coil, place in a Q meter circuit. Now I am doing some adjustments for the Q meter. Listen. Listen. See here. Ratio of the voltage across. If you see, ध्यान से देखिए आप एक बार सब लोग एक बार ध्यान से देखिए. Ratio of voltage across a capacitor to the supply voltage is equal to Q factor. If the input voltage E is kept constant and the voltage appearing across the capacitor is Q times of E. So this voltage is kept constant and this voltage is the capacitor voltage. If EC is equal to Q times EC is equal to somewhere, it is equal to E. That is a Q times of E. So you are going to get the Q factor. So that is a way how to find out the Q factor. But here, when it comes to practical, we are having a circuit of the Q meter. So this is a practical Q meter, dear students. If you see this one, this is a practical Q meter. Why? Because Q factor you are going to have at a particular frequency na? At a particular frequency. So at what frequency you are going to have? At high frequencies you are going to have. That's why for different frequencies you have to do it. That's why we are using what circuit here? Oscillator circuit. Obviously, oscillator will have certain frequency na? Oscillator will be giving certain frequency for you. Why? Because resonance is going to happen not for all frequencies, right? Resonance is going to happen for only a set of frequencies, right? That's why I am taking a oscillator circuit. So this oscillator circuit, see here one important point. Now this oscillator circuit से आपने current draw करना है. If you want to draw a current, here I am keeping a shunt resistor. I am keeping a shunt resistor. Why I am keeping shunt resistor? Why? Because oscillator is going to give a waveform. I want to find out the voltage E na. So what is my require? E is required. To get E, I am keeping a small shunt resistor. When a small shunt resistor is kept of 0.1 ohms or 0.02 ohms, see, I have kept a shunt resistance of 0.02 ohms, then maximum current comes here, so we are going to get a voltage. So this voltage can be measured by a voltmeter. So this voltage is our E voltage na, E aa gaya. And this is our unknown coil. Dear students, this is our unknown coil. I will explain about this CD later. I will explain this CD about later. I have taken the coil and I have connected this to a variable capacitor. Are you finding this variable capacitor? Yeah. Now this variable capacitor is connected to the terminals, so that what I am doing, I am adjusting this particular capacitor voltage and I have kept voltmeter here. So all of you understanding this voltage is EC. So how many voltmeters are there? 2 voltmeters are there. One voltmeter is for E, another voltmeter is for EC. All of you clear about this point, dear students? So this is the practical diagram of Q meter. The circuit of Q meter is taken such a way, we have to get a voltage of E. To get a voltage of E, I am keeping a shunt resistor here. So shunt resistor ke across I have connected this voltage. So the voltage across the shunt is equal to this voltage. This is the voltage given to the circuit. Why? Because at resonance frequency, the entire circuit becomes purely resistive circuit, so I will get voltage. I am keeping the capacitor here. The unknown coil is given. This is the test coil. The test coil I am keeping here. So for the test coil Q factor I have to find. I am going on adjusting the EC. At a particular value of C, I am going to get EC such a way that is equal to E. समझ में आपको? So listen, dear students, how to understand some theoretical points I have mentioned here for the sake of your understanding. See, oscillator deliver power for small resistance. See, oscillator will deliver power to small resistance RSH of order, so that the small value of resistance is added in the circuit. Definitely remember, RSH is added in the circuit. A standard variable capacitor is connected in the circuit. Coil under test would be connected across T1 and T2. Where we are connecting the coil, dear students? Coil we are connecting at T1 and T2. समझ में आपको? I am explaining the total circuitry because Rahul Jaiswal GATE 2020 में question पूछा है. Ruchita, for instrumentation people and for electrical people also regularly एक question आ रहा है Q meter पर. Very easy question. Okay. Now, dear students, listen. Here I want to tell you how to measure the Q factor now. To measure the Q factor, what is the concept? To measure the Q factor, here I have written some theory. See, actually what is the Q factor? The oscillator is set to desired frequency and then tuning the capacitor is done adjusted for the maximum value of EC. This is important. Why we are using thermocouple voltmeter? Ruchita, thermocouple voltmeter is best suitable for high frequencies na? Ruchita, thermocouple voltmeter is best suitable for high frequencies. Resonant frequencies are going to be very, very high. Resonant frequencies are very, very going to be high. Yes or not, Ruchita? Solve that question. Which question? Kamal Gupta, what you are asking? Please give some respect while you are posting the comments. Okay. So when resonant frequency is very, very high, so the instrument should be independent of frequency na. So frequency independent hona hai na. Frequency independent voltmeter hona hai. Frequency independent voltmeter bolo to we require thermocouple voltmeter or not? Do you remember? Thermocouple instruments are best suitable for high frequency measurements or not? Yes or not? Yes or not, dear students? Kamal Gupta, I am coming to that question. You should have patience. Ruchita, your doubt is clarified. Why? Because Q factor is going to be achieved at a particular set of frequencies. So the frequencies are going to be very, very high. So at that particular frequency, normal voltmeters, if you take moving iron voltmeter, if you take PMMC, if you take dynamometer type voltmeter, they are having some problems na. They are having certain problem. That's why we are going for thermocouple instrument. Thermocouple instruments are best for high frequencies. That's why I am going for that. Now, dear students, if you observe here, one important point I want to tell you. If you observe, clear, Ruchita, your doubt is clear? I think Ruchita, your doubt is clear. We are using the thermocouple instrument for high frequency measurements. Why? Because we are using radio frequencies here. We are using this particular instrument for radio frequency. So this frequency is most important. For high frequency, we have to have thermocouple instrument. Now, dear students, how to understand this problem? Actually, in this particular theory, Q factor theoretical कितना है? Q factor theoretical कितना है? Omega L by R. Am I right? Actually, how you are going to get the Q factor value? We are going to adjust the EC value and we are going to adjust the E value. If you take the ratio of EC to the E, you are going to get this is the true value now. This is a true value. But if you observe the circuit, Q practical, if you observe carefully, in this circuit we are having R in series with a shunt resistor is also there na, dear students. In series a shunt resistor also there na. I think all of you watching the circuit or not, dear students. In series we are having a shunt resistor or not. This particular shunt resistor will be in series to this resistor na. RSH will be in series. So Q practical will be what? Dear students, once again I am telling you, Q theoretical will be omega L by R. Q practical will be what? Omega L by R plus RSH na. R plus RSH. So if you take R common, that will become 1 plus RSH by R. Omega L by R is theoretical na. So Q theoretical by 1 plus RSH by R. Am I right or not, dear students? Am I right or not, dear students? So once again I am telling to you, you have to remember this for exam. Kamal Gupta, are you there? Kamal Gupta, please wait over there. I am coming for the question. Q theoretical true, omega L by R. Q measurement, omega L by R plus RSH. So if you take R common, 1 plus RSH by R, omega L by R Q theoretical, this is Q measurement, or this is true value also you can write. This is true value. This is true value. This is measurement value. And this is error or not? This is error. 1 plus RSH by R is error. Do you understand? This is the expression you must remember. All of you clear about this? Equation number 1. Maza aa raha hai? Yes or not? Yes. This is the correct measurement. So generally Q factor value what you are getting will be some number, but when you are measuring you are using the shunt resistor also. Similarly, if you go to the circuit, one more thing I want to tell you. In terms of Q factor का formula और एक भी है. Q factor का formula और एक भी है. क्या है? Dear students, Q factor का formula और एक भी है. जल्दी बताइए. Q is equal to 1 by omega CR ना? 1 by omega CR or not, dear students? Yes or no? 1 by omega CR. What is this C? C is a variable capacitor na? This capacitor. This C is a variable capacitor na? Yes or no? Please tell me fast. But remember, when you are using the coil, every coil generally, the coil is also having some capacitance or not. I think all of you know. When high frequency current is going like this, then what happens? This particular internal capacitance will be generated or not. So here this one charge and this one charge. So this forms one capacitor and this forms one capacitor. This forms one capacitor. There will be multiple capacitors. This is what we call distributed capacitance. Dear students, following or not? For a coil, it will be having capacitance or not? Why? Because when the current is passing through these turns, what happens? Here also we are going to have certain charge or not? Charge entering, charge leaving, like this. We are also having certain charge or not? So this particular edge will form one capacitor, this particular edge will form one capacitor plate, this particular edge will form one capacitor plate like this. So this is what we call distributed capacitance. What we call? Distributed capacitance or intern capacitance. Coil intern capacitance. Yes or no? Yes. in terms of capacitance. Yes or no? That is important. So that is what we have. Actually, it is not connected. It is not external capacitor. That's why I am showing the dotted line. Have you observed here the dotted line, Ruchita? We are observing a dotted line here. This dotted line represents what? Distributed capacitance. Distributed capacitor. Now, when it comes to reality, this distributed capacitance and this capacitance दोनों parallel में होता है ना? So Q true is this. Q measurement क्या होगा? Q measurement क्या होगा? So this particular variable capacitor and distributed capacitance दोनों parallel में हो जाएगा. So that will become omega C plus CDR or not. मजा आ रहा है अब? All of you understanding, Rahul? So that is a formula. True value is this, measurement value is this. That also if you write here, once again, fast. Q true is equal to 1 by omega CR. So this is variable capacitor. Okay, Q measurement 1 by omega C plus CD distributed capacitance. Am I right or not? Now here also we are going to have an error. If you take this expansion omega CR plus omega CDR, so if you take omega CR common, this will become 1 plus omega CDR by omega CR. Am I right, dear students? Am I right? So omega R gets cancelled. So 1 by omega CR is nothing but Q true value. So Q true value by 1 plus CD ना, sorry 1 plus CD by C ना. बोलिए भैया जल्दी बोलिए, जोश नहीं है आज का क्लास में क्योंकि डेरिवेशंस कर रहा ना, इसलिए जोश नहीं है. Q measurement will be this. समझ में आपको? This is मजा आया? बार बार मैं ऐसा हिट कर रहा हूं, These are the expected questions. You can ask you the questions in terms of distributed capacitance, you can ask you the questions in terms of measurement capacitance. Chalo. So what we can measure with Q meter? We can measure the Q value. Next, we can measure the CD value, coil का internal capacitance, and we can measure the inductor value. क्या क्या measurement कर सकते हैं? देखो, what we can measure with Q meter, what parameters we can measure? Q meter से हम क्या क्या measurement कर सकता है? First, Q factor of a coil. By using which formula? Q is equal to EC by E. Khatam. Done. Second, we can also find distributed capacitance CD value or not. Distributed capacitance कर सकते ना? कैसा कर सकते? Distributed capacitance कैसे calculate कर सकते? See, first I will do one thing. Before that, we can find out the resonant frequency. Resonant frequency calculate कर सकते ना? 1 by 2 pi square root of LC. ओके ना? अगर आपको resonant frequency मालूम है, पर्टिकुलर कैपेसिटेंस, देन यू कैन फाइंड द इंडक्टेंस ना. इंडक्टेंस भी कैलकुलेट कर सकते हैं ना. नेक्स्ट मोस्ट इंपॉर्टेंट पॉइंट, आई विल टेक ए पर्टिकुलर रेजोनेंट फ्रीक्वेंसी. एट ए पर्टिकुलर रेजोनेंट फ्रीक्वेंसी आई विल एडजस्ट द कैपेसिटर वैल्यू. दिस इज एक्चुअली इज L into C, बट रियलिटी क्या है? L into C plus CD ना. ये स्टूडेंट, this is the actual theoretical, but this is the resultant actual measurement में क्या होगा? C plus CD आएगा ना. Are you understanding? Now what I will do? This is, who is the variable in this? Dear students, who is the variable? C is the variable. This is the coil parameter or not? Coil's distributed capacitance. Am I right or not? Coil's distributed capacitance. So if you want to find out this, first set a frequency, go on varying this, you will get certain Q factor. Next set this and go on varying this such a way FR2 is equal to 2 times of FR1. See here, I want to show you. Yeah, dear students, listen carefully. I have collected all the data for you. चलो, yeah, so we have done this 1 plus RSH by R. Next, yeah, we can find out the measurement of inductance. Clear? We can find the measurement of inductance. F is equal to 1 by 2 pi root LC, and from that we can find out the inductor. Next, one more thing, we can find also the effective resistance. We can also find the effective resistance. How many of you know effective resistance? What do you mean by effective resistance, dear students? What do you mean by effective resistance? What do you mean by effective resistance? See, dear students, this is the coil. I told you this coil is having inductance. This coil will be having resistance. This coil will be having internal capacitance. Effective resistance means this resistance is purely dependent on the frequency also, dear students. It depends upon the frequency also. As the frequency of your current is increasing, frequency of your supply is increasing, then what happens? The resistor also going to be changed. The resistance also going to be changed. That's why remember, resistance is a function of frequency. All of you understood? Why? Because there is one concept called skin effect. I think all of you know that skin effect. If you take a resistor, in a resistor electrons are normally flowing in the center. In a center. But whenever a high frequency is happening, then what happens? This particular current, these electrons will be dragged towards the skin. Dragged towards the skin. Am I right or not? These electrons are going to be dragged towards the skin. So because of that skin effect, what happens? The obstruction to the electrons flow will be going to happen. So that improves the resistance. The more is the frequency of the supply. The more is the frequency of the supply, the more is the skin effect of a conductor or not. The more is the skin effect, the more will be the resistance or not. So this resistance only we call effective resistance. Effective resistance purely depends upon the frequency. Clear, dear students? This is going to be for coils especially. This is going to be for coils. Effective resistance depends purely on the frequency. So coil effective resistance we can get from this omega L by R. Okay, na? So Q is equal to omega L by R. If you observe, R is equal to Q. R is equal to what? R is equal to what? Omega L by Q. All of you understood, dear students? All of you understood? R is equal to omega L by Q. Omega is frequency. As the frequency changes, this effective resistance also changes. As the frequency changes, effective resistance changes. As the frequency changes, the coil's effective resistance changes. This is a beautiful point. This word should understand effective resistance. Effective resistance is a beautiful word. Just like in physics, according to de Broglie's theory, mass is different, effective mass is different. I think you know this. M and M star, M bar, H and H cap. You know these terms? In physics you will get M and M cap, H and H cap. These are what? Effective terms. Effective terms. Effective terms. Generally we will think mass of the electron is constant, but whenever electron is moving, its effective mass is going to be changed. Do you write? Rahul Gupta, Rahul Jaiswal, Kamal Gupta, Mamata Kulkarni, all of you understanding what I am saying? Generally mass of the electron is constant, but whenever the electron is in motion, according to the lambda is equal to h by mv, the mass is going to vary. The effective mass is going to be different. Do you remember? This is P, h by P, momentum, physics aaya. There is one concept called mass, effective mass. Similarly, there is one concept called resistance and effective resistance. How many of you agree this? How many of you agree this? Resistance and effective resistance, mass and effective mass, especially for instrumentation students, you must be very clear about this concept. Why? Because in optical instrumentation, light is a wave. When the wave touches the metals, in the metals the electrons velocity is going to be affected. Photoelectric effect, when light touches the metal plates, when light touches the metal plates, because of the energy of the light, internal electrons का effective mass बढ़ता है, इसकी वजह से वो बाहर आता है. That is what we call photo emission effect. Photo emission effect. Effective mass अलग है. Similarly, effective resistance भी अलग है. Effective resistance purely depends upon the frequency. When frequency increases in the conductor, the electrons are going to move to the skin. स्किन इफेक्ट बढ़ता है. अगर फ्रीक्वेंसी बढ़ गया, स्किन इफेक्ट बढ़ गया. अरे ऐसा जाने वाला इलेक्ट्रॉन्स ऐसा ऊपर जा रहा है, इसकी वजह से फ्लो ऑफ इलेक्ट्रॉन्स का ऑब्स्ट्रक्शन हो रहा है, उसकी वजह से रेसिस्टेंस बढ़ रहा है, रेसिस्टेंस बढ़ रहा है, रेसिस्टेंस बढ़ रहा है. इफेक्टिव रेसिस्टेंस समझ में आपको? इफेक्टिव रेसिस्टेंस Gajendra, effective resistance. This is called effective resistance. I am using the word effective resistance. Effective resistance purely depends upon the frequency. Okay na? Clear Gajendra? Effective resistance. चलो. So हम क्या क्या मेजरमेंट कर सकते हैं? Q मेजरमेंट कर सकते हैं, फ्रीक्वेंसी मेजरमेंट कर सकते हैं, इंडक्टेंस मेजरमेंट कर सकते हैं, एंड इफेक्टिव रेसिस्टेंस भी मेजरमेंट कर सकते हैं. ओके ना? चलो. और क्या है? And remember, measurement of self capacitance. This is also important. क्या measurement कर सकते हैं हम? Self capacitance. Self capacitance means what? That is our coil's capacitance. The self capacitance of coil is determined by making two measurements. First, what I will do? Self capacitance होता वही है. हमारा जो कुछ coil है ना, coil का resistance मालूम है, coils का inductance मालूम है, coils का distributed capacitance होना है ना, coils का distributed capacitance. This is what we call self capacitance. So वो कैसा पता चलेगा? वो कैसा पता चलेगा? So first what I will do, the variable capacitor I will adjust by taking one frequency. I will take at a particular frequency f1 and I will take a c1 and cd is this. Okay na? First I will fix a resonant frequency. Dear students, listen carefully. First I will fix a resonant frequency, and for a particular value of c1, variable capacitance C1, I will achieve the Q. Okay na? First I am fixing a frequency, I am adjusting the C1. Yes. I am adjusting the frequency and adjusting the C1 so that resonance can be achieved. Next, I am increasing the frequency. Dear students, listen carefully. This is most important to understand. I am increasing the frequency and changing f1 to f2. ये बात समझना बहुत important है. I am changing this f1 to f2, but I know this f2 is 2 times of f1. क्योंकि resonance is going to be achieved only for a particular set of frequencies, right? Resonance is going to be achieved only for a set of frequencies, right? First, I will choose a resonant frequency. I will go on adjusting this variable capacitor. Then I will get the Q. At that time, I can get the value of the formula 1 by 2 pi root of LC plus CD. उसमें unknown कौन है? Unknown कौन है? CD. Okay. Next, I will increase the frequency f2 such a way f2 is equal to 2f1. f2 is equal to 2f1. For new frequency, again I will vary the capacitor C2 and I will observe the resonance. So f2 is equal to 2f1. f2 क्या है? 1 by 2 pi square root of L. So this is achieved at a particular capacitor C1 plus CD. This is fixed, this won't change. Next, 2 f1 1 by 2 pi square root of L C2 plus CD. So ये दोनों में CD constant है ना dear students? ये दोनों में CD constant है ना? All of understood dear students? Now 2 pi gets cancelled. So if you take the square, 1 by L C1 plus CD is equal to 4 by L CD plus C2. Sorry, C2 plus CD. C2 plus CD, LL cancel होता है. So 4C1 4CD. So 4C1 plus 4CD is equal to C2 plus CD. So 4C1 minus CD, 3CD. So you are going to get some expression now for CD. Please फटाफट tell me here. 4C1 plus 4CD is equal to C2 plus CD बोलो तो 3CD is equal to 3CD is equal to C2 minus 4C1. So from this you got CD now. CD is equal to C2 minus 4C1 by 3. All of you understood, yes students? Distributed capacitance मिल गया ना आपको? Distributed capacitance मिल गया? All of you understanding? कॉइल का पूरा पैरामीटर्स आया, कॉइल का रेसिस्टेंस आया, कॉइल का इंडक्टेंस आया, कॉइल का डिस्ट्रीब्यूटेड कैपेसिटेंस आया, yes or not? Sorry. Was mistaken. Done? Clear na all of you? All of you clear na? Yes or not? All of you clear? Yes, correct. Chalo. Now let us go for one question. Chalo, try to do this question. Question. Fast. A coil was tested using a Q meter. A coil was tested using a Q meter and following information was obtained. At a frequency of 3 megahertz, the value of capacitance to give maximum voltage across the capacitor was 251 picofarads. Okay na? Why? Because resonance is going to be achieved. Resonance is achieved means the voltage across the capacitor is equal to maximum. Dear students, listen carefully. Q is equal to EC by E. Ante voltage across the capacitor by voltage in the circuit is equal to Q. Ante voltage across the capacitor is equal to Q times of voltage applied. Ante at resonance, voltage across the capacitor will be maximum. Keep that in mind. At resonance, voltage across the capacitor will be maximum. At a frequency of 3 megahertz, the value of capacitance to give maximum voltage across the capacitor was 251 picofarads. While at 6 megahertz frequency, it was 50 picofarads. Calculate the self capacitance of the coil. Can you do it? See, F1 3 megahertz. At that time, the C1 was 251 picofarads. Next, F2 was 6 megahertz. F2 was 6 megahertz and C2 was 50 picofarads. So just before we have done that expression, what is that expression? We got that expression. F2 is equal to 2F1. If you do, you will get the answer. So CD is equal to, what was the formula? CD is equal to C1 minus 4C2 by kitna? 3C1 na? Am I right or not? Let me do it. Fast. C1 plus CD. F2 is equal to 1 by 2 pi. Just before you have done na, L C2 plus CD. F2 is equal to 2F1. So 1 by 2 pi root of L C2 plus CD is equal to 2 times of 1 by 2 pi root of L C1 plus CD. So 2 pi gets cancelled. So 1 by L C2 plus CD is equal to 4 by L C1 plus CD. L gets cancelled. So 4C2 plus 4CD is equal to C1 plus CD. C2 minus C1 plus 3CD is equal to 0. So CD that's it. What is the answer, please? Yes, only 3. 17 picofarads. Chalo. That was my mistake, right? Only 3 here. Calculation. So what is the answer? Please substitute fatafat. C1 is given 251 minus 4 times of C2, 200 by 3. So you will get how much? 17 picofarads. Other students, what happened? Are you doing or not? Distributed capacitance का question आ गया 17 picofarads. Other students, are you doing 17 picofarads? Get practice of these questions. Chalo. These are all previous gate questions. Yeah, answer is 17 picofarads. Next question, try to do it. Next question. A coil with a resistance of 0.1 ohms. A coil with a resistance of 0.1 ohms is connected in practical Q meter. DVM नहीं हो गया गजेंद्र सिंह, DVM नहीं हो गया. A coil with a resistance of 0.1 ohms is connected in practical Q meter. Resonance occurs when the oscillator frequency is 40 megahertz and the tuning capacity is set at 135 picofarads. Calculate the percentage error introduced in the calculated value of Q by a 0.02 shunt resistance connected across the oscillator circuit. How to do it? Question is visible or not, dear students? Question is visible or not? Chalo. Fast. A coil with a resistance of 0.1 ohms is connected practical Q meter when the oscillating frequency is 40 megahertz and the tuning capacitor is set to 135 picofarads. So what is the true value? True value will be what? Q true will be omega L by R or 1 by omega CR. 1 by omega CR. He has given the tuning capacitor 135 picofarads. He has given the tuning capacitor 135 picofarads. Calculate the percentage error introduced in calculated value of Q by a 0.02 ohm shunt resistance connected across the circuit. कैसा करना है? कैसे करना है? Yes. Yes, Q practical by Q theoretical. जल्दी बोलिए. Fast. So this is our R. This is our R. This is our RSH. And the frequency is also given. This frequency is also given. So first true Q factor we can find that is 1 by omega CR. 1 by omega CR, that will be 1 by 2 pi F. C कितना है? 135 picofarads. 135 picofarads into resistance true कितना है? 0.1 ohms. Please find out this how much you are going to get. So that is a Q true. Q true. But Q measurement क्या है? Q measurement will be omega L by R plus RSH. That's what just before I have written. That will be Q true by 1 plus of, if you take R common, 1 plus of RSH by R. 1 plus of RSH by R. Can you find out what is the Q true here? How much you are getting? Please tell me, anybody. 1 by 2 pi f into 135 picofarads. How much are? Yeah. So question asked percentage error. Yeah, very good, very good. So Q true, this percentage error means what? Percentage error means measurement value minus true value by true value into 100. So no need to calculate, I think directly we are going to get the answer. Measurement value is what? This one. Q true by 1 plus RSH by R minus true value Q true by Q true into 1. All of you understanding, dear students? So now you are going to get 1 by, yes or not? If you take Q true common, Q true gets cancelled. You are going to get 1 by 1 plus RSH by R minus 1. That is a percentage error. So please simplify. 1 by 1 plus RSH by R minus 1. Please simplify. How much you are going to get? Measurement value minus true value by true value. Minus 1 is going to come. Dear students, minus 1 is going to come. Prashant Kumar, minus 1 is going to, Rahul, minus 1 is going to come. Measurement value minus true value by true value na. Measurement value is this, Q true by R common liya, 1 plus RH by R, omega L by R, that will become Q true. Yes, Q true by 1 plus RSH by R minus true value, Q true by Q true. Q true if you take common, that will be 1 by 1 plus RH minus 1, Q true gets cancelled. So this is the error. So what is the answer? 1 by 1 plus RSH कितना दिया क्वेश्चन में? RSH 0.02 ohms and 0.1 ohms. 0.02 by 0.1 minus 1. Yes or not? So answer बताइए. 2 by 100. 0.1. फटाफट answer please. Yes sir, negative will be coming. Yes, negative will be coming. So 0.02 divided by 0.1, 0.2 plus 1, 6 by 5, 5 by 6, minus 1. We are going to get minus into 100, into 100. So that will be coming minus 16.66%. Got it? 16.66%. मजा आया? This was the last year gate question. This was a previous year gate question. Previous year gate question. PYQ. Minus 16.66%. Very good. Minus 16.66%. Clear now? Shall we go for one more question? We'll go for one more question. Very good. Chalo. Yeah, minus 16.67%. Yeah, try to answer this. Visible now? Question is visible? A reading of 120 is obtained when a standard inductor was connected in the circuit of a Q meter. So Q meter का value दिया है, Q factor का value दिया है. One more, very good. So this is Q दिया है, Q factor दिया है. A reading of 120 is obtained when a standard inductor was connected in a circuit of a Q meter and the variable capacitor is adjusted to a value of 300 picofarads. So variable adjusted capacitor C is given. A lossless capacitor of unknown value Cx is then connected in parallel with a variable capacitor and the same reading was obtained when the variable capacitor is readjusted to a value of 200 picofarads. The value of Cx in picofarads is dash. Question you have to understand clearly. Dear students, this is our supply voltage E, this is our coil, this is our capacitor. This is our capacitor. Okay na? So here the point is what? First, a reading of Q120 is obtained when a standard inductor was connected in the circuit of a Q meter and the variable capacitor adjusts to a value of 300 picofarads. So when it is at 300 picofarads, the Q value is how much? 120. Next, a lossless capacitor of unknown value Cx is then connected. So this is the supply voltage. So this is the coil. So now for this particular capacitor, a lossless capacitor Cx is connected in parallel. Maza aa raha hai? For the C, a Cx is connected in parallel with variable capacitor and the same reading was obtained. Same reading means what? 120. Same reading was obtained. Same reading was obtained when the variable capacitor is readjusted to a value of 200. That means what is the value of Cx? Very simple question. If you understand, it's a very simple question. See, you got Q value of 120 when this capacitance total is 300 picofarads. Now another value of Cx is kept here and this value is varied at a particular value of 200 picofarads. You are getting this as again same 120 means what is the Prashant? Do you understand the question? First only single capacitor, this is varied at a particular point of 300 picofarads. I got 120. Now another parallel capacitor is kept, then definitely the net capacitance is going to be disturbed. Now I am adjusting this at a particular value of 200 picofarads. I am getting this as 120. And ये कितना है? जल्दी बताइए. That means you are getting the same Q factor. 120 means this total should be 300 na. We'll get E from, no need Rahul Jaiswal, no need of E. Why? Because the Q meter reading is same. Q meter reading is same. 120 means this capacitor is asking how much it should be. You got 120 when this total is 300. You got 120 when this is 300. Why Q? No need of Q, yaar. No need of Q. Why Q? Not necessary. Why? Because the same Q factor na. Same Q factor means this should be same value. This total capacitance must be 300 na. So this is already 200 picofarads means this is 100 picofarads na. That's it. Why? Because you are getting the same reading na. You are getting the same reading बोलो तो ये capacitor, this picture can be replaced with this picture. This picture can be replaced with this picture. So जो कुछ भी capacitance इधर है that should become to 300 picofarads ना. It should become 300 picofarads. उसने already एक capacitor दिया है 200 picofarads. ये माल unknown calculate कर सकते ना. Beautiful. चलो. So answer कितना है? 100 picofarads. मजा आया? Interesting? Lovely. ऐसा क्वेश्चन आया, बहुत अच्छा क्वेश्चन आया. Okay. So please practice all these questions. Ruchita, clear? Yes, capacitor in parallel added as series resistance. Yes. Okay. Other parameters he has not given na. Other parameters he has not given. Yes. Correct. Chalo. Enough for today. I hope all of you enjoyed the session. So tomorrow we'll start one beautiful topic. Okay. Clear all of you? I hope all of you benefited from these sessions. I have done some beautiful problems also on Q factor. Okay. So please go through the session again and again. You will get beautiful questions. Good questions. Okay. My dear students, I hope you have enjoyed the classes. Please share these classes in your WhatsApp group, Telegram groups. Whatever the questions, daily we are discussing around 5 to 6 questions daily we are discussing, right? So please forward. Your mouth publicity matters to us a lot. So you have Telegram channels, right? Gate Academy Telegram channels are there. So there in Telegram channels, your feedback you please throw. Today all of you, Prashant Kumar, Ruchita, Rahul Jaiswal, I am asking you to please share the feedback of this class, measurements class, in the Gate Academy Telegram channels, in the Gate Academy Telegram channel, so that other electrical students, other electronic students also will come to know that this measurements class is going on, so we have to attend that. Sir, I want to meet you. Okay, thank you. We'll meet after your Gate examination is over. Definitely you will come to me with a sweet box. Chaliye. So I request all of you to share your feedback in the Telegram group. There is a Telegram group. Immediately after the class is over, how much you have enjoyed the session, please post over there, so that other students will come to know. Other students will come to know. Okay na Kamal? Okay na Rahul? Other students will come to know. Why? Because so many students are busy with other subjects like power systems, machines. Okay, they also have to come na. So because my class is at the evening, 9 o'clock. Okay, so try to understand. Thank you, Richita. Thank you. Please go through all these. Please go through once again all these problems. Okay, please go through all these problems. Okay, please go through all these problems. So we have discussed the beautiful content here. The content is also good for you. So you can go through all these problems. So good night. Tomorrow we'll meet again. We'll discuss some more questions. Okay na? Chalo. Thank you. Tata. Take care. Bye bye. Love you all. Take care.